Good day everyone, and welcome to this final video, to this sixth video in a series of videos illustrating the range of the tangent function. In this video lesson, we will review the concept of odd functions. So what makes some trigonometric functions odd functions? So let's discover the answer together. So let us show or prove that the tangent function is an odd function. An interactive GeoGebra applet was created, and let's answer a few questions together. So question number 1. So let's compare the first and fourth quadrant angles of the same magnitude. We have an angle of 10 degrees in the first quadrant. What is the standard position of an angle with the same magnitude in the fourth quadrant? Alright, so option 1, 10 degrees. Again, that's at the first quadrant. Negative 350 degrees. That would bring us at the first quadrant. 340 degrees, yes, it is a fourth quadrant, but it has a magnitude of negative 20 degrees. So the answer is negative 10 degrees. Very good. When we say angles in standard position, we mean an angle with a vertex at the origin and with an initial side at the x-axis. Right, so question number 2, coterminal angles and their tangent values. So what angle is coterminal with negative 10 degrees? Yes, that would be 350 degrees. So we can say that tangent negative 10 degrees is equal to tangent 350 degrees, right? Because they are coterminal to each other. Now, observe the spreadsheet. What is the value of tangent 10 degrees? And the value of tangent 350 degrees. So tangent 10, that's 0.1763 something. And then tangent 350 degrees is negative 0.1763. Their absolute value are equal. And let's compare the value of tangent 10 degrees and tangent 350 degrees. Are they equal? No. Are they both 0? No. Are they reciprocals of each other? No. But they are negatives to each other. Their absolute value are equal, right? Alright, very good. Which means that for tangent 10 degrees and tangent negative 10 degrees to be equal, we need to negate tangent 10 degrees. So this explains why the tangent function is an odd function. And besides, the tan function has the y-coordinate as a factor. Here's our last question for this video. What property of the tangent function can we observe? Which means that tangent negative theta is equal to negative tangent theta. Example, tangent negative 10 degrees is equal to negative tangent 10 degrees. Yes, the tangent function is an odd function. Alright, so as a recap, we have observed that negative 10 degrees is coterminal with 350 degrees. Hence, negative 10 degrees is equal to 350 degrees. And we also have observed that since tangent 10 degrees and tangent 350 degrees are negatives to each other, we can also conclude that tangent 10 degrees and tangent negative 10 degrees are also negatives to each other. What is the implication? So for tangent 10 degrees and tangent negative 10 degrees to be equal, we must negate tangent 10 degrees, right? So as a conclusion, we can express this as tangent negative 10 degrees is equal to negative tangent 10 degrees. This illustrates that the tangent function is an odd function. We denote the odd function property of the tangent function with this notation. Tangent negative theta is equal to negative tangent theta. Now, why? What makes a trigonometric function an odd function? So please observe these odd functions and tell us what factor is common to all of them. Do they all have the x factor? Do they all have the r factor? Or do they all have the y factor, the y coordinate? Yes, all of these functions have the y coordinate. And we observed a while ago that the y coordinates in the first and fourth quadrants have opposite signs. So again, the y coordinate in the first quadrant is positive, and the y-coordinate in the fourth quadrant is negative. Therefore, for the values of the odd functions in the first and fourth quadrants to be equal, we need to negate the values of the odd functions in the first quadrant. Final conclusion, so each tangent curve signifies that the range covers all elements of the real number system from negative infinity to positive infinity. And as a performance test, please feel free to replicate any of the GeoGebra assets or models and verify findings. So I would like to thank Dr. Sirag, the author of the pre-calculus book that I reviewed, and Mindshapers Company Incorporated for publishing such a book. And to all of you who are watching the video lessons and reading the teaching document, thank you so much. So again, this is Tutor Man, and I hope that you have learned something.